Kia ora, Year 12 and Year 11. This is question 9 from the June 2021 AS Pure 1 exam paper, and I'm just going to get through question 9 in this video, and it's a geometric progression question and then an arithmetic progression question. So there's going to be quite a bit of algebra. So the first part, we're told that we've got a geometric progression is such that the second term is equal to 24% of the sum to infinity. So the first thing to remember is that the sum to infinity in a geometric progression is the first term over 1 minus the common ratio. And the sequence or the progression goes like this. It goes A, and then we've got A times R, and then A times R, and so on. So the second term is this one here. So what do we know? Well, AR is equal to 24%, so 0.24 times A over 1 minus R. And we need to solve that to find the possible values of R. So we know that the first term is not going to be 0, and that means that we can divide both sides through by A. So straight away we get R times 1 minus R is equal to 0.24. So sorry about the background noise, but there is tiramisu being made in my kitchen right now. So R minus R squared is equal to 0.24. Now we've got a quadratic, that's going to be a pain in the neck to solve. So we might just make that 24 over 100 and go from there. I'm going to simplify that fraction first up. So that's 6/25. So I've got 25R minus 25R squared is equal to 6. You can see that we've got a quadratic. So we're going to end up with 0, 1 or 2 solutions. So 0 is equal to 25R squared minus 25R plus 6. Now, my brain is hurting a bit looking at that. I could do the quadratic formula. I'm not going to do completing the square. You could do, but this is an odd number, so it's going to be a bit messier. I'm going to use grouping for this one. So it's good practice at going over grouping. Remember, grouping is also called the AC method, and we're going to take this. So we're looking for two numbers that when they multiply together, they give me the A times the C, so they give me 150, and I need the gap between the numbers to be 25, right? So the product of these two numbers is going to be 150, and the sum of them is going to be negative 25. So let's think about two numbers that are going to multiply to give me 150 and add to give me 25. Well, I must have two negative numbers for that to happen. So we've got negative 10 times negative 15, and negative 10 plus negative 15 will give me negative 25. So we can rewrite this as 0 is equal to 25R squared minus 10R minus 15R plus 6. We're going to factorize this, and we will get what? Let's see. Well, we've got 5R into 5R minus 2 minus, factorizing this and looking for that repeated term, it's going to be 3 5s are 15, so minus 3 times 5R minus 2. So we've got 0 is equal to 5R minus 3 times 5R minus 2. So 5R minus 3 equals 0, or 5R minus 2 equals 0, giving me my two possible ratios of R is equal to 3/5 or R is equal to 2/5, just solving those little equations there. Okay, so that's the first question done. Let's see. Right, so find the possible values of the common ratio. Yep, that one's fine. Now the next one is not conceptually difficult, but you do have to be just a little bit careful not to make errors with it. So we've got two arithmetic sequences or progressions, and the first one is the really basic one with the first term is A and the common difference is D, right? So P goes like this. We've got A, turn that off, A plus D, and then A plus 2D, and so on. Sequence Q has got a first term of 2 times A plus 1, and then a common difference of D plus 1. So it's going to be 2 times A plus 1 plus D plus 1, and then it'll be 2 times A plus 1, and now we've got two lots of that difference will be here, blah, blah, blah. Okay, so if you've got a clear picture of that, then this question is not too bad. So we also want to know the formula for the sum of n terms in an arithmetic progression. So the sum of n terms is equal to half of n times 2a plus n minus 1 lots of the common difference. Now we need that because we're told that we've got 2 bits of information. We've got the 5th term over the 12th term is equal to 1/3. And then we've got this information here about the sum of the first 5 terms. And you know that we've got to work out A and D, and so we're going to end up with 2 simultaneous equations to solve. Right, so what's the 5th term of P? Well, the 5th term of P will be, so we've got A plus D, A plus 2D. So it's going to be A plus 4D, right? And the 12th term of Q, well, the 12th term of 2 is going to have 2 lots of A plus 1 plus, so when we're in the second term, we've got 1 lot of D plus 1. The third term has got 2 lots. So the 12th term is going to have 11 lots of common difference in it. Okay, so we've got this, and that's the equation that we're going to have to simplify first, right? And then we're going to have this one here to work with. So I'm just going to go on to a new sheet and work through that, and I'm really sorry about the background noise. Okay, so in this one here, we've got A plus 4D over 2 times A plus 1 plus 11 times D plus 1 is equal to 1/3. So cleaning that up gives me A plus 4D over 2A plus 2 plus 11D plus 11 is 1/3. Right, I'm doing this really slowly because if you don't, you're likely to screw it up and make mistakes, and then it won't all work out nicely. So 2A plus 11D plus 13 is equal to 1/3. And now we've got 3 times A plus 4D. Okay, so on the right-hand side, we've got just 2A plus 11D plus 13. I think this is the boringest question in the whole paper, but there you go. So 3A plus 12D is equal to 2A plus 11D plus 13. So if we clean that up, we get A. Let's just do it as an A's and D stuff over here. So A plus D is equal to 13. Right, so that's going to be the first of my 2 simultaneous equations. So let's go back now to that question and see what we've got to do with this next bit. So we've got the sum of the terms now, the sum of the first 5 terms of P and the sum of the first 5 terms of Q. Right, so I think we need a new page for this one. So remembering that S of n is equal to half n into 2a plus n minus 1d. So the sum of the first 5 terms of P is going to be a half times 5, and then we're going to have pretty straightforwardly 2 plus 4d over the sum of the first 5 terms of Q, right? So Q has got that for the first term and that for the common difference. So again, it's the first 5 terms in Q. So we've got 2 times the first term and then 4 lots of the common difference, which is d plus 1. So this looks terrible, but it's not really. And we're told that that equals 2/3. So the first thing you notice is that we can simplify that away. And then we have 2a plus 4d over 4a plus 4 plus 4d plus 4 is equal to 2/3. Oh, don't know why that just happened. There we are. Right, now we've got 2a plus 4d over 4a plus 4d plus 8 is equal to 2/3. So you can definitely simplify this in a few different ways, right? But I've just cleaned it up to that first. Now we've got 6a plus 12d is equal to 8a plus 8d plus 16, and I could divide everything through by 2, but I'm not going to. I'm just going to see what I've got. I've got negative 16 as the constant is equal to 2a minus 4d. But now I am going to divide through by 2. Okay, negative 8 is equal to a minus 2d. So that's my second equation. Now we're going to solve that simultaneously with my first one from the sum to infinity. So I've got 13 is equal to a plus d. All right, so those 2 equations there. I'm going to do equation 1 minus equation 2, lots of different ways you can do this, but doing this, we get negative 21 is equal to negative 3d, giving me d is equal to 7. Right, so d is equal to 7, and a plus d are 13, so a must equal 6. So there you go. That's question 9 done, and we've found the value of a, and we've found the value of d. Now you can see that that was a 6-mark question, illustrating the fact that there are lots of little places that you can go wrong in there. But if you are confident with your sum to infinity, that was for this one here, but if you're confident with your sum to n terms, I don't think that question is that difficult to see what needs to be done. It's just easy to make mistakes along the way. All right, thanks for watching. Sorry about the noise. I have moved, so there's no more tiramisu, and I'll finish off questions 10 and 11 later on today.